So let's talk about Ohm's law. And let's just, so to compare, let's create a resistor, a circuit made of resistor, an LED. Let's give it green. And let's just close this circuit here. Not good in drawing, but I did my best. So we have a resistor here, we have an LED here, and we have, let's just make a different color. I'm using Sketchbook. It's an Autodesk software. Just download it. It's really great for drawing. I'm still learning it. So let's make a plus sign here and a negative sign here. Okay, and let's say we have 5 volt power source, like when you connect, for example, your laptop to your Arduino, you will provide 5 volts. So you just use 5 volt for now. Okay, and now let's compare these circuits. So since we're going to be talking about voltage and Ohm's law, let's make a simple analogy to understand current and resistor and voltage. So let's draw a water tank. Okay, all right, so water tank, let me just get red again. So just gonna make something simple here, not a fancy drawing. And let's imagine, well, kind of just erase this a little bit. It wasn't center. And let's make some kind of pipe going down like that. All right, just make it thicker. And this is our water tank, and let's just fill up the tank with water. So let's just put a nice blue here, and so imagine water is streaming down here. I like these colors. So I just want to be a little bit fancy with the coloring. You know, you can play with it to make it better looking, but so this is our water tank. So the water creates some kind of pressure because of height. So you just compare this pressure made by water, like the water pressure, like the voltage. So I'm just gonna write a V from down there, from top there to here. This is our voltage. So when water because of the height, the pressure of the water is going to be higher on top. So this is high here. I'm just gonna change maybe the different color, red. So this is high and this is low in the bottom. Okay, and this height, that's what's going to make the water flow through here. I just change the color again. So the this pressure here, and it's this pressure that makes the water flowing from top to the bottom. And because of that height, water is gonna be pressured and come down this tube right here. Okay, the same analogy, because of this differential potential here it's 5 volts in the plus side, and here is the low side, like what we had here, is 0 volts. So because of this differential potential, sometimes we call it electromotive force, which is known by voltage. This is actually what make current flow. So the electrons will flow, and same thing, the water will flow because of that pressure. So enough of this drawing. Now let's go back to Ohm's law. Ohm's law basically says resistor or voltage equal I times R. I is the current, and R is the resistor of the material. And what we need to find what is the value of R. Okay, so there is, because of the we have 2 components in series here. We have resistor and we have an LED. So there is a voltage drop in each component. So there is a VR and a VL. So I'm just going to put in parentheses here V total, which is 5 volts. I'm going to call that V total, equal to VR plus VL. So really VL rating of the LED we have. So it's approximately about 2 volts. And we also have the current, the operating current of the LED, so we don't burn it. It's going to be I equal 20 milliampere. And ampere is the unit of, write it down for you, ampere is the unit of current, and it's in milliampere. 1 milliampere equal to 10 to the power minus 3. Remember that, ampere. Okay, so now we need to find, we have the voltage. This is like an equation with unknown. So we have the voltage drop at the LED. We have the total voltage. The only thing we're missing is the voltage drop at the resistor. And for that, we use this equation here. We have VR equal VT minus VL, which is 5 volts minus 2 volts, which is equal to 3 volts. Okay, so we know VR now equal to 3 volts. Okay, to calculate the R, we go back to Ohm's law. R is equal to V divided by I, and V this time we're going to use the VR of the resistor, which is 3 volts. And since these 2 components, the LED and they are in series, the current flowing through the LED is the same as the current flowing through the resistor. So by the way, when I say currents, I mean the conventional currents. So conventional currents will flow always from positive going to negative. So always go from here and it goes back to the negative terminal. But actually what's happening is completely different. The electrons, because of that differential potential I was talking about, here it's a 0 volt and here it's a 5 volt. Okay, so this differential potential make force electron to move from negative terminal to join the positive terminal. Okay, so different charges attract each other, so the negative will go, and this is actually what happened physically, but everyone now is using the conventional currents, so we'll just use with for now, I mean that's what we use is the conventional currents. Alright, so our conventional current, the operating value of the LED is 20 milliamp. So remember we have to convert to ampere, so we have to multiply that by by 10 to the power minus 3, and this value is equal now to, if you do your math, it will be 1.5, and you simplify this to the power 2, which is going to be 150 ohms, and ohms is the units of the resistor. So now let's say you have a resistor with the color band, like this one for example. We have red, red, brown, and it has a fourth band which is gold. It might look yellow in the screen, but that's gold, okay? And you want to know what value is this. So on the right hand, I just made this table here, and the table basically, the first column, it will give you the color of that you choose, either black, brown. So black is number 0, and the column next to it is the number, the code number for that color, specific color. So let me just explain you how it works. So for example, for this one, the first color is you read from left to right. So the first color is red, and I go and look up, okay, red is number 2, so I put number 2 here, okay? And the second color, as you see here, is red again, so again is number 2, so I write down number 2, okay? The third color is brown. That value, let's look it up. Brown is number 1. So the third band is multiplier, like you see here. So what we do here on the multiplier, we take that number corresponding to the color, and we just do, for example, 10 to the power 0. That's going to be our multiplier, and that's equal to 1, okay? So for brown is 10 to the power 1, which is really equal to 10. It's pick another number. So for example, for orange is 10 to the power 3. That is equal to 1K. That's 1K, 1 kilo ohm, okay, resistor. And blue, for example, is 10 to the power 6, and that's how it continues, which is like 1 mega ohm, okay? So the same thing here. We're gonna multiply the brown by, we're gonna multiply the 22 by 10 to the power 1. That will give us what? 220 ohm resistor. And this is how we calculate our resistor. So really the resistor that we have here is R equal to 220 ohms plus or minus some tolerance, and that's what the fourth band is gonna give us. So for example, we have color gold is plus or minus 5%, okay? If we had silver, it will be plus or minus 20%, so plus or minus, this is plus or minus. And if we don't have any color, that's a higher tolerance. So to calculate the tolerance, so basically RT, I'm just gonna call it R tolerance, is you take the 220 ohms and you multiply it by 5, and you divide the whole thing by 100, and you can do the math, you know. That's how you calculate your tolerance. Thank you.